Yes, audible, Zaid.
Mhm. Yeah,
Yeah.
I can hear you. Mm-hmm.
So yesterday we have seen some properties of probability. Okay, so and solve some laws related to that. So now we will
Mm-hmm.
see an advanced model of probability that's called as a bit further, which is called as conditional probability. As the word suggests, a name only suggests you probability. So it's very easy concept, by the way, if you go conceptually. So what is the probability? Conditional means when probability is
Mm-hmm.
calculated based on some condition, when probability is calculated
Yeah.
or seen, calculated, or you can see observed, calculated or observed based on some condition, based on some
Mm-hmm.
condition, then it is known as conditional probability. So we'll see how conditional probability exists. Okay.
Mm-hmm.
Let me start from you.
Give me a minute.
Conditional okay, okay, I'll give you take your time.
Okay, I'm back. Hello?
Yeah.
I'm back.
So conditional probability and independence. So I have written there probability based on some condition is known as conditional probability. So we'll see what's first conditional probability, and independence is also a
Mm-hmm.
what you'll say a concept in probability. So we'll see it further. So first we'll try to understand what is first of all conditional probability. So the probability of an event can change if we know that some other event has occurred. For instance, suppose you toss a fair coin twice. So what will be the uh, output? We are trying to explain conditional probability. So he's telling that suppose we toss a fair coin twice. So what will be the sample space? Okay. So that's the sample space. Now see. So the probability of getting two heads. In it, the probability of getting two heads. So let it get two heads. We
Mm-hmm.
get two heads. So this is the set builder form. The roster form will be HH. So what is the probability of A? You know, number of elements in A upon number of elements in
Mm-hmm.
sample space. Yes or no? One by four. As you should be very what you say generous about calculating the simple probability. You must practice it hundreds of times, different examples, 50 to 60 different examples, so that as fast as you see the example, so that fast you must give the answer what is the probability of that specific event. Okay. So one by four because the sample space contain
Mm-hmm.
four equally likely outcomes. Correct. Suppose that first two lines tails. Suppose that first two lines tails. Now what's the probability of getting two heads? It's zero. Yes or no? What is telling that the
Mm-hmm.
first toss lands tails. So, for example, I'm tossing. For in a real world, if I'm tossing, okay. So now we are getting the probability that we get two heads. So in our sample space, for example, first land tails. Everywhere first is tail. Everywhere first is tail. It can happen that on the second it may have head. On the third it may have tail. On the second again it may have head. Okay, but first has landed tail. Okay, this is not possible because this is the repeat. So what it did first landed tail. Now what is the probability that it will have what you will say tail on both the head on both the sides? So it will be probability of A will be 0 upon 4 because there is no chance. So that's 0. Yes. So now what's the probability of getting two heads? It's 0. Knowing that first toss is a tail changes the probability that you got two heads. Yes or no? He has changed the condition that first
Mm-hmm.
toss was tail. First toss was tail. So we have put a
Yeah.
condition on it. So our sample space has changed as well as our answer of A also has changed. Yes or no, Zay?
Yeah.
So what we have observed? So we have observed that if observe that if we apply some condition on our experiment, condition on our experiment, it can be a condition on the experiment or the event, then the probability changes. Then the probability value changes. Then the probability value changes. This change is due to the condition that is implied. Is due to the condition that has been implied. That has been implied. So hence it is known as it is known as conditional probability. Got that? Yeah. So knowing the first toss is a so This idea is the key to many applications of probability. This idea is a key to many applications of probability. So this idea of conditional probability is very important to know. So what is conditional probability? Let's return to the college statistics class from section 5.2. Earlier we used to use the two-way table shown on the next page to find the probabilities involving event A is male, B has a pierced ear for a randomly selected student. Okay, is my voice clear, Zaid?
Mm-hmm.
Okay.
Yeah, your voice is very clear.
Okay, so let's return to the college statistics class on section 5.2. Earlier, we used to use the two-way table shown on the next page to find probabilities involving event A is male and B has a pierced ear. So we have used what we have done here in the earlier. For example, I'll take the table first of all, then we'll see the expression of. So we have used this table so such that A, for suppose we want to find the probability that it is male and it is he has a pierced ear. So where will we go? Here. We'll add this number. Male and sorry, we'll take this. Male and pierced ear. So what will be 19 upon 178? Yes or no? That's the thing. So we have done this thing. So okay, so has male and a PSL for randomly selected student. So what will be the probability of A? So the probability of A here he has explained. We'll have to take it again on board. See here. So what's the probability of A that he is male? So male are 20/90, correct? So 90 only male. Probability
Mm-hmm.
of A means male, only male. That they are male, so it will be 90 upon 178, correct? So B pierced here. So B is pierced here. So it is total pierced here is 103. So it will be 103 upon. This simple probability we know how to calculate. So now we have to calculate probability of A intersection B and A union B.
Mm-hmm.
So means what we want, what do we want generally? Probability of male and pierced here. Male and pierced here. Male or pierced here. Male or. Here
Mm-hmm.
and this and or makes a very large difference. And means common, common between both, and or means both will work. Both will work.
Mm-hmm.
I'll write more description down. Both will work means if it is male, this will also work, or if it is pierced here, this will also work. Okay. Here it cannot happen. It should be both here in this case. Okay. Then only it will fall in this category. Here anyone will be work. Okay, will be work. That's the thing. So this is, by the way, easy to calculate. So where is the intersection between these two? Here, 90. Yes or no? But
Mm-hmm.
can you tell me where is the union of these
Yeah.
two? Union means where they are both. So we need to, I think, add this. So we'll see how he's doing. Okay. So now let's turn our attention to some other interesting probability question. If we know that a randomly selected student has appears here, what is the probability that a student is male? Okay, so for suppose it has a pierced here. For suppose we have fixed that he has a pierced here. Okay, now what is the probability that the student is a male? So first of all, we have fixed that he'll having a pierced here. Now what's the probability that he is a male? So after pierced here we have fixed. So male, how much we have? 19. And now as we have fixed that he is a pierced here, we have fixed that we have selected a student with pierced ear. So what is the probability that, so first of all, when we have not selected that it was a pierced ear, so what it was, here, and I'll do, and here this one 19 upon 178 the total. But what will be, it will be here, see here, it will be 19 upon, as we have selected it is a pierced ear first only, condition is applied, so what will be the total? 103. So it will be 19 upon. So has the probability changed or not? See, yes or no? Are you getting that? When
Mm-hmm. Yeah, I got
it
that.
was not fixed, it will be male and pierced here. We would take 19 upon 178 and a intersection. 19 upon 178.
Mm-hmm.
Yes. But now what we have done, we have fixed
Yeah.
that the boy, the person choose is male, is pierced here, has a pierced here. Okay. So now we have to look into the pierced here column. Okay, this, yes, pierced here. Now how much there are male? 19. But the total are 103. That's the reason the probabilities have changed. See, we'll do it on calculator also and see the magic of conditional probability. 19 divided by 178. What it is? 0. 19 divided by 178. How much it is? 0.1067. 0.1067. And what is 19 divided by 103? It is 0.18. 0.18. So the probability here has been increased. Here it is increased. Yes or no? Due to condition, it can happen. It can increase also and it can decrease also. Here it has increased. Got that, Zaid? What is the difference?
Mm-hmm.
So see here. So there are 103
Yeah,
students in the
I
class
got the
which are
difference.
pierced, correct? So our sample space will be 103. We can restrict our attention to this group. How I have restricted here. See how we have restricted here in this. I've told you that here we have restricted our attention here. That we look into this only, this column only. Okay, that's the thing. Since we are told the chosen student has a pierced ear because there are 19 male among the 103 which are pierced ear. So male given pierced ear is C. 19 divided by 103. Correct? So that's the thing. So if we know that the randomly selected student is a male, what's the probability that the student has a pierced ear? So now what we have fixed? The second one, what I'll do, I'll pick it. Pick this one. Question also. So now what we have fixed that the student is a male. So I have fix this column. So we'll look into this only. Okay. Now what we have to look after fixing male, what's the probability the student has a pierced here? So it is 90. So how much is the sample space? The sample space has become 90 as we have fixed that it is a male, and what will be A? That it is a pierced here. Pierced here. Okay. So the number is 19. So what is the probability of A? It will be 19 upon the total number of sample space. It will be 9. Got that? 19 upon
Mm-hmm.
90, 0.221. That's the thing. Is it easy, say? Very easy
Yeah, pretty
by the
easy.
two-way table? Yeah, that's easy enough.
Yeah.
I have a throat swollen today, so I'm having difficulty in speaking. Okay. So that's the thing. This is how we have
Mm-hmm.
to calculate. So these two questions sound alike, but they actually ask two very different things. Each of these probability is an example of conditional probability. The name comes from the fact that they are trying to find the probability that one event will happen under the condition that some other event is already known to have occurred. So means first we are considering that the first event that they were choosing a male has already occurred. Then we are up to finding the probability that after choosing a male, we have to choose a pierced here, or after choosing a pierced here, we have to find a male now. So one conditional we are fulfilling.
Mm-hmm.
In previous condition, in the intersection here, in the intersection, in this part, in the intersection, what we were doing, we are finding the probability of both, and here also in the union both. But in the conditional one task is fulfilled, then we are going to the other task. So what will be A intersection B? It will be 19 upon 178, by the way, because intersection here it is. Okay. And what will be A union B? We need to do probability of A plus probability of B minus probability of A intersection B. So what it will be? A plus B. What is probability of A? Means that it is a male. So it is 19 upon 178 plus what will be the probability that pierced here. So it will be 103 upon 178 minus it will be 19 upon 178. So the total, I think it is
178, yeah.
193 minus 19 upon 178. So what it will be?
Will be
Minus
one
83, 183. So
one
183
one
and
two
173, I think.
140
172.
180 174
No, 172.
172.
Correct, na?
I think it's
No.
174.
Yes, 174 about it. See, what's the probability? How much big is the union? This is for the union, huh? Union
Mm-hmm.
means it is probability of A union. So
Yeah.
these are different things. Union and intersection are different things. Here we are considering both the event are happening in one instance. Okay, choosing of the male also and
Mm-hmm.
choosing of the peers here also. We are calculating probability of both. Okay, so this is the thing. This is not the same case with the probability, conditional probability. In conditional probability, I'll write here. Probability, it is assumed that the condition that is put forward has been fulfilled first only. Has been fulfilled first, and we try to find the probability of the given condition fixing the first one. Fixing the first one. That is the thing. Means the first which they have chosen, we fix it like that way and try to find the probability of the second. That's the things. Conditional probability. The probability that one event happened, given that the another event is known to have happened, is called. Is known to have happened means have happened further only. It's called as conditional probability. The conditional probability that event A happens, given that B has happened, is denoted by. We'll take this.
Yeah.
So
Can you
see,
give me
when
1 minute real quick?
yeah, yeah, yeah.
Okay, got it.
Okay, so on we were that conditional probabilities that probability that so it's telling that the probability that one event happens means A had happened given that another event is known to be happened. So B is to be happened is called a conditional probability. The conditional probability that A happens. A happen means A will happen. Is happen to left will happen or is happen to left. A is happen to left means it will happen to take place and B has already
Yeah.
happened before.
Mhm.
Means B is the condition means B is the condition on which.
Mhm. Yeah, I can understand that.
So we are written as probability A given B. So remember the line A given B. Like
Given B.
the line is what you will say back, forward slash. There is a term in probability also that this is called as A minus B. A minus B. And this is called as A given B. A given B means B was given and we need to find A. Okay. There's a difference. So you cannot change the line. Okay. Note this difference. Is that clear?
Yeah, I can understand.
Yeah. So with this new notation available, we can restate the answers to the question just posed as so that we have solved further. So that the two things that we have calculated that male given that it has Pierce tier is 19 upon 103 and Pierce tier given that it was a male it is 19 upon 90. So here an example that illustrates how conditional probability works in a familiar setting. So that's the thing. So Titanic disaster. So there is a formula, by the way. I'll give you the formula first for conditional probability. So what's the formula for A given B? The formula is probability of A intersection B. What we need to find? Probability of A intersection B. And you have seen that
Mhm.
what condition is fulfilled, we take the total number of it. Probability of B comes in now. Probability of B.
Yeah.
Or you can
Okay.
write it as number of elements in A intersection B upon number of elements in B. The same thing. Because here, when you are finding the probability, why I'm telling this formula is very useful because we will use directly this one. It is easy because what will be the probability of A intersection B? It will be number of elements in A intersection B upon number of elements in sample space. The same upon what will be the probability of B? Number of elements in B upon number of elements in S. The denominator and denominator get cancelled. What we are left with? Alhamdulillah.
Well, that's with this the N A union B.
Correct. A intersection B. No, intersection. A intersection B upon number of elements in B. So
Oh,
that's
it's
the thing.
intersection. Oh yeah, it's
Yeah.
intersection.
Remember this. In conditional, it's intersection upon what comes the condition number of elements of B. Same as if we are calculating probability B given A. Both are possible. A given B as well as B given. So what it will be? Number of elements in A intersection B. This numerator remains same. This numerator remains same. The thing changes is the
Mm-hmm.
condition number of the condition which we have applied on that number of elements come into the denominator. Got that, Zain? So we'll write once more
Yeah, I got that.
the differentiation A given B. So it is number of elements in intersection upon number of elements in B because it is a condition. Same probability B given A. So it will be number of elements in the intersection upon number of elements given on the condition. So that's the thing. So okay, generally we have
Mm-hmm.
used generally this formula in calculating when we have calculated further these one. These when we have calculated we have used this formula only, but the formula we have not learned. That's the reason. But I have given you now the formula. Okay. Okay. Read the question. Come on.
Mm-hmm.
You have to solve it. The whole question you have to solve it. Come on. And give me the solution for it. I'll just take a
Mm-hmm.
2 minutes break from my side. You just solve it, and then after 2 minutes, I'll ask you the answer. Okay.
Mm-hmm. Uh, let's see. Third class citizens that survived. 151 over 442. I guess is that mm, I'm guessing just 197 or no, it's 191, 245 or 442. Yeah, okay. Okay, got the answers. Hello? Are you there?
Hello. Okay, okay. I'm back. Okay, so tell me the answer. I'll read the question once, then I'll ask you. Uh, So suppose we are randomly select one of the adult passengers from the library, define events F as first class passenger and F survive and T third class passenger. Take this on our board. Okay. So find T given as so P uh, and so what we have to be probability of T given S. So first of all, we need to list it what is T and what is S. So it is third class passenger given that S survived. We have to first of all survived. Survived is the condition that's fulfilled. So survived. So survived number of elements in survived. So number of elements in survived is 442. Yes or no? So in 442, this
Mhm.
survived we have to fix. The condition given is survived. Now we have to look for the third class passenger. So they are 150. So that's 151. Say the same answer you got, Zaid? Yes or no?
Yeah.
Okay, so you need to interpret also this value, how you have calculated. So first we have fixed that the number of passenger that survived, so that was 442. So number of passenger that survived is 442. In that column, we have to look for the passengers that were third class. So the 151 were third class. So we have written that here.
Mhm.
So we have written that here. Okay, so that 151. So that's the thing. So given that the chosen person is not a first class passenger, what's okay? Now what we have to do? Given that chosen person is not a first class passenger. Chosen person is not a first class passenger. What's the probability that she or he survived? So not a first class passenger means we have to reread this. Not a first class passenger.
It's just 151 plus the 94.
What it will be? Just give me
It'll
151
be
plus 90. Correct. It will
2,445.
be
245 out of
5 and 9.
442.
245 upon this addition will be both now. We have to add this also. No? This we'll add or
But I
what we'll
said
add?
those who survived.
Correct. So no, wait a minute now. Chosen that given that the first chosen person is not the first class person, what's the probability that she or he survived? Okay, she or he survived. All right, your answer is the probability using correct symbols for the events. So what we have to find first of all that what's the probability that she or he has survived? Okay, We need to find the survive. What we have fixed the second and third class. Yes or no? We have fixed the second
Mhm.
and third class now. So fixed is this.
Mhm.
So we need to add this total. So this will be 8, 8, 8, triple 8, and how many of them survived in the survived class? We'll leave this. So that's the answer for my sense.
Mhm.
We look into what he has given. So
Mhm.
it is 151 upon 442, and for the second answer, C. Understood that what is fixed, it's very important. What you are doing, you are fixing this. Survived. Okay. We have to look for survive. Yes or no?
Mhm.
Correct? This is not
Yeah.
fixed. It is P S given what you will say. ST, second and third class. Okay. This is very important. What is fixed in this sense? If you don't know what he has fixed, then it will be very difficult and every time you will go wrong. Okay. So, is there is a connection between conditional probability and conditional relative frequency from chapter 1. So wherever we have learned probability, we have learned percentage. So we that relative frequency means we'll write it and in percentage. Yes, in part A of the example
Mhm.
we found that conditional probability 151 upon 0.342. In chapter 1 we asked what proportion of survivors were third class passengers. Okay. So conditional relative frequency we have studied in the chapter 1. That conditional relative frequency where we have conditionally relative and calculated the marginal what you say marginal addition of the all two and then we have written there. So in chapter 1 we asked what proportion of survivors were third class passengers. So our answer was third class first we have to look. Okay, and then survivors. So it was 151 upon 442. Yes or no, Zaid?
Mhm. Yeah.
Yeah, so then it is the same. This is the conditional relative frequency because we are finding the portion or proportion of the third class passengers amongst those who survive. So conditional probability is just a conditional relative frequency. So conditional probability is same as conditional probability is same as conditional relative frequency. Conditional relative frequency. And understood. So relating those two. So in this case, randomly selecting an adult passenger. Let's look more closely at how conditional probabilities are calculated using the data from the college statistics class from two-way table shows that follows. We see that. So male and Pierce here. So male and Pierce here, it is looked as male. So it is 90 and Pierce here is 19. So 19 upon 103. Okay. First of all, it is Pierce here. No? So Pierce here we have fixed. See, if you make a mistake in what is fixed, what condition was given, this is the condition, Pierce here. So I've fixed this column. Okay, this column I fixed. So what is the total? 103. So we have written 103 and in that male is 19. So 19 upon 103. Okay.
Mhm.
Same thing here. See what we are doing generally, what I have explained you. Yes or no?
Mhm.
See what he is trying to do. What is trying to do? Probability of male given pierced here. So what he is trying to given? Probability of male intersection pierced here upon probability of pierced here. Yes or no? So male
Mhm.
intersection pierced here is 19 upon 178 given by male of pierced here is I think 103 upon 170. 103 upon 170. So generally it get cuts and the formula comes 19 upon 103. So he'll give you the formula. See what he gives. He'll give the general formula for calculus. See what I have given you. Understood? You can write in number of this also. Are the formulas clear?
Mhm.
Yes or no?
Yeah. Yeah.
Okay. We have done the formula, so we'll not spend time on this. We'll flip on to this. Come on, tell me. Read this question and tell me the answers.
I'm guessing 68 times, well,
Survey of
68 times
followers.
28
So
divided by 28.
68% use for Facebook, 28% use Instagram, and 25% Google. Suppose we select a resident at random, given that the person uses Facebook. So we have fixed that he uses Facebook. So what I'll do, I'll take this out of a board. So Facebook is there 68%. So we have fixed. That is it. So it will come into the denominator. See now when it comes 68%. Okay. Or you can write it as 0.68 also. Okay. This is the condition. So suppose we select as a given that the person uses Facebook. What's the probability that she or he uses Instagram? So Facebook intersection Instagram. So it uses Instagram. So we have to use this both. Intersection means both. So it is 25%. So it is round about 0.25. We'll remove the point of both. It will be 25 upon 68. That's the answer. Got that? So if you will divide,
Oh, it's just 25 divided by 68. Okay, that was the addition
yeah,
thing.
that's the thing. Simple. 0.3676. 0.3676 means what is the probability? That is 6.76. What I have done,
0.3676%.
see
Yeah.
what I have done, probability of Facebook intersection Instagram upon probability of what was fixed Facebook. Instagram intersection Facebook means what we have to find probability I given F means F is fixed and we have to find I. Got that? Yes or no? So that is the thing.
Hmm.
Here both
Yeah.
means intersection. This both means intersection.
Yeah.
So see. Got that? Yes or no?
Yeah, I
Okay.
got that.
Yeah. So refer back to the example. If a person chooses an Instagram user, what is the probability that she chooses Facebook? So if he's an Instagram user, we'll change the question now. We were finding Instagram given Facebook. What if he was an Instagram user? Facebook given Instagram. So it will be probability F intersection I, F intersection I. This is same. Huh? F intersection I you write or probability of F I intersection F. This is the same. Okay, both of the intersection. You change, it doesn't change this, but the denominator will change. So it will be 25 upon Instagram is how many? It's 28%. So it will be 25 upon 28. So see, 25 upon 20. Got that? Yes or no?
Hmm. Yeah.
Yeah, so that's okay. So what is the example is giving? You can write statement like probability given B if events are. So I think we'll discuss this topic more further tomorrow. I'm not well also, by the way. So we'll see this in deep tomorrow and we'll start independent scheme even tomorrow. Is it clear, Zaid? Okay,
Hmm. Yeah.
so let's stop here. Just pray for me that my throat gets well soon. I have
Hmm.
the
Yes.
Assalamu alaikum. Allah Hafiz.
Okay. Walaikum salam.